without further ado, coming to tonight's session on how every company will be an AI company. Let me give an introduction to our very distinguished and eminent speaker of tonight, Mr. Prateek Gupte. Prateek is the Vice President at Haptik, a conversational AI platform which has been acquired by Reliance Jio. After leading the engineering team at the company, he moved into product management to build Haptik's B2B products and business. Prior to this, he was the co-founder, CTO at a multiplayer gaming company, BYOF Studios, and the founder at Code Red. A very warm welcome to you, Prateek. We are absolutely thrilled to have you here with us tonight. Handing the session over to you now.
Thank you, Shima, for that introduction. I'm excited to be here, and thanks to everyone for joining a webinar so late in the evening. So yeah, let me jump right into it and share my screen. Awesome. So, I'm here today to talk about the future of technology, or rather the future of all companies, all enterprises, and how today we talk about, Haptik and other companies being AI companies. But the future is really that every company will incorporate AI. Every company will be a software company. And I'm here today to talk a little bit about that and how you can, as a product manager, as an entrepreneur, as a leader, incorporate some of this technology starting today and hopefully provide you guys with a path to get there. So a bit about myself, like Shama mentioned, I was most recently Vice President of Product at Haptik. I led the product team over there for the B2B business, as well as initially I was the head of engineering over there. And I've recently moved on to start another company of my own. And prior to that, I was a two-time founder as well, starting in mostly in the gaming space with BYOF Studios and Code Red. Great. So, this quote, I won't, will attribute to its original speaker, Satya Nadella. He was actually on a panel a few years ago with the CEO of Mercedes, Daimler Chrysler, and he was talking about how if computing is now becoming a core part of every industry. A car is no longer just a car; it's also a computer. And in 10 years, he's predicting a future where there won't be a distinction between a software industry and tech industry and every other industry. Every sort of industry today, you are already seeing this change where they're incorporating technology in such a way that it's extremely critical to their operations. And if you try and sort of shy away from it, you're gonna get left behind by companies that are technology first. And this is causing disruption in today finance, in agriculture, in pretty much every e-commerce, every industry that there is, right? And when you think about it, software is eating the world, and now AI is a very, very crucial part of that software. So it's not about just separate tech companies or separate AI companies. Make sure that you, as a product manager, as an entrepreneur, have that skill set, have the tool set of being able to understand AI, identify opportunities within your product, and be able to apply them. And that's sort of what I hope to cover today. So, like I said, a couple of key takeaways for today are, I'll provide a non-technical math-free primer on machine learning problem statements and categories. Hopefully you can use these and apply these in sort of your product and your business. And I'll also cover another really crucial aspect of building an AI company or building integrating machine learning tech, which is the design side of it, how to integrate great user experience for your end users. And finally, we talk a bit about how to set these expectations and how to work with customers and stakeholders when you have an AI first business. It's actually a little different from traditional businesses in terms of the way you set up contracts, the way you sell the product itself. So just sort of a quick disclaimer right over here. I won't sort of be covering about actually how ML works and some of those technologies, etc. There are plenty of courses out there in terms of Udacity, Coursera. There's a great course by Andrew NG. So do make sure to learn about the technology in detail yourself. In today's talk, I'll primarily talk about the business outcomes and the product perspective of it. And as you do so, make sure that you're providing this AI training to all the other people within your company or to your co-founders, such that they have a perspective and business stakeholders have a perspective of the technology as well and what it can do for them. Great. So let's jump right into it. So the talk today, the name of the talk is, talking about how every company is going to be an AI company. But I thought that, just kind of clarify some of these nomenclatures. So artificial intelligence is a broad sort of term that encompasses a lot of different things. It essentially is a technique which enables machines to mimic human behavior. And that includes multiple different fields. It could includes RPA, it includes robotics, it includes multiple different disciplines. A subset of that, of these AI techniques, is machine learning, which is essentially enabling machines to make decisions and off of data, and so that you can codify their decision making without defining it in a static way. And using this data, machines can be used to make decisions and get outcomes. And a further subset of that is deep learning, which is another sort of way of using multi-layer neural networks to make those same decisions. So for the sake of today's talk, we're going to look at machine learning as a whole and not make the distinction between whether you should use deep learning, whether you should use simple machine learning and statistical models. The end outcomes and goals you will get from both of these are essentially the same. The decision whether to use a deep learning model or not is more that I would say is more of a technical decision, and you can leave to your engineering counterpart to make that decision. So, what are the real opportunities for ML, and how do you look at these problem statements from a more um, product outcome or a more of a problem perspective rather than a technology perspective, right? And you can essentially think of these problem statements in six main ways. Your first category of problem statement is ranking, recommendation, classification, then there's regression, clustering, and anomaly detection. And I'll try and explain each of these with an example so you can get an understanding of where you can kind of use these mental models to search for problems you can solve with this technology. So the first category is ranking, right? And everyone's probably seen ranking. The most common one is a search term, Google search results on Bing, etc. Uh, Essentially, the the generalization of the problem statement is that when a user provides a specific parameter, it could be a number, it could be a category, it could be a search term, providing an ordered search set of results to that user. So we're seeing this over here in Google search results. They also do a bunch of other different things, but primarily it's a ranking problem statement. We're trying to move a finite set of results in an order such that the most relevant result is at the top. It's also seen in e-commerce sites. You'll see them on those are a combination of recommendation and ranking system when you say people bought things similar to you, etc. The second one is a recommendation system. This is slightly different than a ranking system. In a ranking system, in a ranking category, a user has provided some sort of input, and then you're ranking those results based on that finite set. Whereas in a recommendation system, you're trying to find out what a user is going to be explicitly interested in. And say the most common one is a very popular example of this is Spotify's Discover Weekly playlist, where it understands your preferences based on your previous learning patterns as well as other input you give to it. And it's able to provide a recommendation list to you that, hey, you will probably like these songs as well. It uses a bunch of different techniques under the hood, but essentially it is an example of a recommendation type category. Another sort of example would be when Twitter or Netflix recommends to you um, to friends you might like or people you might want to follow. That's another sort of example of a recommendation system. Another example is another type of category is a classification system, where over here, where essentially you are trying to put things into a specific, whether you're trying to say if something is or is not or something. And let me give you an example. So the spam filter in Google, where you're trying to basically classify whether an email is spam or whether an email is not spam. All this is another example of classification is any sort of image detection, where you're trying to sort of look at a picture and say, is this an picture of person X or is it not? Is this a person of picture Y or is it not? This is sort of a classic example of a classification where there is a defined outcome you want to kind of identify. The next problem statement is a regression. This is where you're essentially trying to predict something. So let's say you're trying to predict a price of what flights will be in the future. And over here, kayak hotels and flights is a perfect example where they're trying to tell you whether the price will rise or whether the price will drop in the future. And they're trying to predict the price basis previous data that was given to them. And again, there is a sort of defined outcome you're trying to get, you're trying to predict the price. The fifth example is an example of an unsupervised algorithm, and that's a clustering algorithm. And over here, I'll take an example of something we built at Haptik. Over here, what we try to do is find clusters or group together pieces of information which are very similar to each other. So let's say, for example, this screenshot tries to identify groups of things that the bot did not understand. So these are sort of say policy number, policy agent over here. You can see these are certain topics that the bot did not understand. And we try to identify and cluster these groups together to kind of create those categories. There's no sort of previously defined input to this algorithm. We're not saying we want to identify a cluster with agent or a cluster with policy, but we're trying to say, tell the machine learning system will recommend to us that these are the clusters we found. Another example of unsupervised learning algorithm is anomaly detection. We're trying to find, given a data set, something that stands out. And an example of this would be it's used a lot in finance, where you're trying to say find a stock which is trading out of character. Or another example is in Twitter, a trending category. So essentially, a trend is something that's an anomaly from all other behavioral patterns you're seeing. That these trends or these topics are growing at an unnatural rate as compared to other Twitter topics. And it's trying to identify and surface this anomaly to you. So these are your 6 main sort of broad problem categories. Again, you can solve these using deep learning, you can solve these using ML. That's sort of irrelevant for today's discussion. We're trying to still bucket sort of what we can do with these problem sort of categories over here. And you're trying to find a business outcome for these categories. So once you kind of identify these patterns in your data or these patterns in your product, the next thing for you to do is clearly identify the business outcomes. And again, the outcome here is not necessarily the same as the use case. So what do I mean by that? Let's take an example of Spotify and Discover Weekly. What they were trying to do is increase usage of customers and make sure that people come back to the app more. And people should like the music that they're being recommended. That is the business outcome, that my net user retention increases, my engagement increases. And the use case over here is that I will recommend a way for users to discover more music. And if they like that music, then they will stick around. Another example would be for the hotel booking example, right? Over there, the end business outcome we want over there is that people should make more bookings. And by showing them that information, we're giving them the confidence that yes, now is the right time to make the purchase, or now is not the right time to make that purchase. So have that business outcome really clear in your mind, and it'll make guiding decisions and make sort of taking those calls as to whether what you built is working or not working a lot easier. The first step for you is to quantify that business outcome, right? So let's say you have a certain booking rate or a conversion rate on Kayak. You need to know what that is first before you introduce the ML algorithm, or the ML feature that you want to introduce. You need to baseline that. And let's say, for example, my conversion rate is 2% or 3%. I need to know that number before I deploy the ML technology. And you need to then measure the outcomes after you deploy a recommendation system that, hey, this is the sort of time to make the booking. Does that baseline go up or down? And you'll realize that you have some surprising sort of outcomes over there basis what you deploy. And it's important to have this cycle ready to go before you deploy anything. If you don't know what you're looking for and you don't know what your baseline is, you won't know whether the feature that you've deployed has the outcome that's intended. It might, a lot of times we've seen it's resulted in the opposite outcome, and we'll talk about those examples as well. Another thing to keep in mind is that the outcome is again not necessarily directly related to the model accuracy. You might have a really well functioning model, and it might be an example of an overfitting model, which is too closely aligned to sort of the data that you've given it. But even if you have a great performing model, that doesn't mean that you could get the outcome that you're wanting, the business outcome that you want. So again, another very important reason as to why you should keep that business metric front and center. And start small, right? Start with low hanging fruit. Don't go for the large moonshot where, hey, let me automate my entire purchasing system. Let me automate my entire stock trading system. Start small with recommendations, human in the loop systems, and go from there. And keep it focused around those sort of small iterative systems. So here's an example of a system or ML system that worked really well, but didn't really have the business outcomes that Netflix wanted. So if you would have noticed some time ago, Netflix had a star rating system where you could rate a particular film or a particular piece of content from 1 star to 5 star. And they tried to deploy an ML algorithm which tried to predict the number of stars a film would have before it released. And they tried to use a regression based system for that. And when they deployed it, they found out that, okay, the ML model works really well, but it didn't have the outcome that it wanted, which is it didn't give people the correct, they didn't refer to them the correct piece of content to watch. So it actually had the opposite system, the opposite result. Viewership sort of started to decline because it was just recommending good movies, but not related movies. So what they actually needed was a ranking system, but they deployed a regression-based system, and it kind of resulted in it didn't have the sort of business outcomes they wanted, even though the model performed really well. Great. So let's say, say stage 1 and stage 2 are over. You found out your use case. You kind of thought of, hey, this is where I'm going to deploy a particular ML statement, and I found a piece of my product that I want to automate, so to speak. You've gone and defined your business outcome, where you have now, you know exactly what is the pitch as to why you're making that investment. The next stage is actually collecting the requisite data. And this is a very, very key stage that, a lot of product managers have seen they don't realize that this is part of their responsibility. They think that, okay, now I've kind of defined what I want. Let me kind of hand it over to the engineering team or the data scientist, and they will figure out how to collect the requisite data. They will figure out how to get the training set and make sure that's correct. But this is a joint responsibility, and this is a lot of things that people that are new to deploying AI or deploying machine learning don't get, that data is very, very much a product problem. And finding that data, getting that data, making sure the data is correct and clean is something that is a product manager's responsibility. So there's a couple of ways to go about collecting this data. I'll talk about some of the differences first, and depending on the environment you're in. Let's say you're in a B2B company, it might be a little easier to get the data. You can always ask your customers for that data. A lot of times you'd realize that they already have it. And you can, when you're working with a specific customer, let's say it's supply chain optimization, you want to get an idea of their purchasing and inventory orders, they will usually have that data available. It might not be very clean, but that's a separate problem you'll get to. Whereas in a B2C environment, especially when you're starting out, it's very hard to get that initial data set. So you can imagine when Netflix just started or Spotify just started, it's very hard to release a product or make sure you have that amount of data to be effective. So it's something that gets easier later on, but it's really hard to start with, whereas B2B has the opposite problem. Another thing to keep in mind in the B2B environment is the ownership of data. You might have gotten data from one customer, but you most likely cannot use that data with when you're deploying a solution for another customer. So you need to keep in mind who owns that data, make sure you have the correct legal framework in place to kind of specify that. Similarly, in a startup versus enterprise space, I've noticed that actually as a startup, it's a lot easier to get data because you can kind of deploy that technology and deploy the infrastructure to collect it. Whereas in an enterprise environment, who is the owner of data can be confusing sometimes. There'll be a lot of teams involved, a lot of hierarchies to navigate to make sure that you get that data and such that you have accountability of that. So now, depending on the environment you're in, there's a couple of different ways to go about it. The first example is actually you can buy data, and there's a lot of freely available data sets as well as paid data sets available. You can, depending on the domain you're in, let's say it's finance, or let's say it's NLP or image recognition, you can buy data from a lot of vendors that provide this data for you in a clean and labeled format. Uh, the second option is for you to collect the data yourself. And this is actually something that's a majority of the effort that people tend to underestimate. A lot of the algorithms that are out there today are open source and open source libraries. The differentiating factors and the IPs for company come from the data that they're able to collect. And that needs to be factored into your business plan. It needs to be factored into your cost. So when you start something, make sure you have that cost in mind of buying or collecting the data. The third aspect is once you have this data, how are you going to clean it? How are you going to label it? How are you going to manage that data? And it could be gigabytes or terabytes of data. How do you make sure this data is clean? Because if the data is not clean, then you're going to get a bad outcome, a bad result. It's primarily the quality of your data that affects the quality of your product. And lastly, there's a lot of data labeling agencies as well. You can either do it manually yourself and set up the operational team to label the data yourself, or you can outsource that. But again, keep in mind the cost that will be required to get that done. So the kind of the effort that goes involved is involved over here is something like this, right? Whereas people tend to start from the top and focus on, hey, which technology do I deploy, and how do I get started really with deploying AI and machine learning. But it's actually over here. Your majority of your time needs to be spent on collecting and as much as data as possible. And it could, and getting that framework in place, setting up logging, setting up sensors, generating particular content, and generating, as a product manager, you need to think about not just the technical aspects of this, but also how will you collect this data from users. And that needs to be baked into your product. That's a very, very important key feedback loop I will talk about in the user experience side as well. Once you're collecting enough data, you need to start thinking about how you're storing it and how you're managing this data. And the third part is cleaning. So how do you make sure that this data doesn't have garbage values? It's not sort of, you'll have a lot of uh, bad characters coming in and trying to add random fields, random values. How do you kind of filter that out and make sure that's there? And then you're trying to get first manual insights from that data. Then look at deploying very, very simple ML algorithms. We'll talk about an example of uh, how we started with the feature we saw earlier at Haptik, which was it recommended things that the bot didn't understand. We started with a very simple first data collection, and then we went to a very simple k-means clustering algorithm. And then after that, we realized we want to improve the performance, that this has business value. And then we went to sort of an adversarial model to deploy, which provided us some measure of improvement in performance. But keep in mind this stack, and this is really the hierarchy of needs here. Don't focus on the top. Start focusing from the bottom towards up, and then these activities of feature selection and building your algorithms go a lot easier if you have a strong base for your data science needs. Great. So, we're past step 3. You have defined your use case, you know what your business outcome is, and now you have the data to kind of be able to build that model. Uh, the key fourth part to keep in mind is the actual user experience and design for AI products. It's something that, tends to get ignored, but it's super important. Um, and these are sort of the boundaries of AI, right? Essentially, you're dealing with a probabilistic system, and it really has its own limitations. AI is definitely not foolproof, and that's where design comes into play. By building and thinking of a great user experience, you can really take care of some of the limitations of the technology itself. So let's talk about a couple of best practices and examples over here. Again, looking at the haptic example, something to keep in mind that we always do is we always communicate very transparently whether the system is a bot or whether the system is a human. So you can see, it talks about, hey, hi, I'm via Haptik's virtual assistant. What this does is it sets the expectation that, people know that this is not a person. We're not trying to get away with fooling people that this is a person. That's also firstly the ethical thing to do. But secondly, people, we've tested and seen that people talk differently and chat differently when it's a chatbot versus whether it's a person. And they're okay to give a little leeway to a bot, but they expect a lot more from a person. And setting this expectation upfront helps kind of manage that from users, and they won't end up being disappointed. They won't end up, expecting something that's not possible. The second thing we've done is we've set the context. Here on the right hand side, this sets, an experience that, this is what I can do for you. These are the things that I can help you with. I can help you get the status of your report, find information, get coronavirus information, and other things. And it's not limited to this, but it is sort of setting some sort of boundaries that, hey, I'm not here to talk about everything and anything. I'm here to help you with a specific set of problems, and these are what they are. If the user has some other problem besides these few, there's definitely a typing field here. You can type in anything he wants, but at least there's some structure as to, this is not uh, about the company's financial information or something like that. We've added a clear purpose to the entire sort of interface. The second best practice you'll see here is with Kayak, right? That you want to communicate that this is a probabilistic outcome, and this is the confidence I have in this outcome. So if you can see over here that they've given advice that the price will drop, but there is an 89% confidence, and it's very important to communicate this to users such that they know what they're getting into. They know that this isn't not an absolute sort of 100% certainty that price will definitely drop, right? There's going to be, and the thing with AI is, and the thing with machine learning is, it's always a 0 to 1 number. It's always a probabilistic outcome. Communicate that to users such that they can, basis this confidence, make decisions on their own, and you're not misleading them into something that's not correct. Coming back to the example, of that we had here at Haptik, and you can see we've done the same confidence thing as well over here. And we've also already taken some calls that anything below 50% confidence, we will not show to users. And we've added that threshold over there. What we've also done is, taken a call that these recommendations that this particular new topic will not automatically get retrained by the system itself. We've added a concept called as human in the loop, where we've made a certain recommendation. Now it's up to the person to come in and look at that system and say that, okay, I want to go ahead and retrain the system. I want to go ahead and add this training data back to the particular existing model, or create a new intent, or what have you. It's very important to make this distinction between what should be completely automated and what is okay if it, because it's very possible that this is the recommendation here could have that uh, 19% chance or so chance to fail, right? So you want to have a person in the loop over here to verify that decision. And you've still made the person's job a lot easier, but you've not fully automated it. And that's sort of an assistive technology, we call it. The second example is an iterative product design. So, like I mentioned, this is done with an algorithm called as a k-means clustering algorithm. It's fairly simple, but I know we use that and we deployed that first, and we managed to get that out in a shorter period of time. Uh, Once we saw that, we realized that okay, this is adding a lot of value to customers, and they want to be able to improve on this. And then we want to realize we want to improve the confidence and group things better. That's when we deployed a deep learning technology after that. We had a lot of confidence that it was worth investing an additional 3 months, 6 months to deploy that. And now we'll be releasing a new set of features which will use a deep learning solution and has maybe 5 or 10% better results. So it wouldn't, while the effort to deploy the deep learning solution was double, triple the amount of time, it still gave only 5% more results. So you need to make sure uh, to keep your experiments and keep your releases small. Uh, Release it with the simpler algorithm first, and then look at a big sort of big data sort of deep learning solution. Here's something that an example that you will see in very often, which is you might not have enough data really to make a recommendation or make for your system work. So this is an example of uh, an app that automatically generates playlists for you for when you go for a run. And what the key takeaways here really are to see that this scenario is very much possible where you've initially downloaded the app, you've not saved any songs, you've not found any songs, so it can't really generate the playlist for you. What you don't want to do is create this as an error scenario. This is not an error. You need to kind of design and plan for this, that you haven't added certain preferences for your songs, so I can't make this playlist for you. And this is an error versus this clearly defines what steps the user needs to take next to be able to get that recommendation. Similarly, for Discover Weekly, you can't have a Discover Weekly recommendation without any initial training data at all, right, from Spotify. So you need to build that preference list, and you need to communicate that to your user that there is a lack of data here. These are the steps to take to add that data. If you add 3 songs, the playlist will get generated for you. And this is going to happen because, again, your system is probabilistic. There is always going to be some chance that the system is going to fail. So design for that failure. And it's not really an error scenario similar to how traditional software works. It is part of the design of an AI product. Coming to back to the Spotify example, and we'll talk about a couple of things over here. Um, you will notice on the Discover Weekly section, there are these 2 options over here, which is a like and actually a dislike button. These options are not available anywhere else in Spotify, but only on the Discover Weekly section. So you can mark specific songs as liked or disliked, and then this data is used by Spotify to tune your next week's recommendations. Um, this was a UX choice where now the data science team has that additional data to be able to tune their model constantly and say, hey, let's keep improving our Discover Weekly recommendations. And this is a very, very key product decision to make, that how do I get that feedback and say that, okay, is my algorithm working? Are my recommendations working or not working? So build that as part of your product, as your MVP, as part of your product. It's not something that can be added later on. A couple of other key sort of interesting decisions you'll see regarding the Discover Weekly system. One is that its frequency, or sort of how often it comes. So you only get it every Monday. You don't get it every day. You don't get it every hour. You can't request it. Now, there's a couple of different reasons for this. One is it's expensive. The machine learning algorithm to create recommendations, it might take a day, it might take a couple of hours, and when they're doing that for the entire user base that they have, they can't do it every day. It would be too expensive for Spotify. That's one. Secondly, you have to look at the results. Maybe you're getting only 20 sort of good recommendations every week. Now, it wouldn't make sense to kind of, create 10 playlists a week if you have only 20 good recommendations. So you want to set that frequency up to weekly. Again, that's a very important product decision that was taken. That's the reason why this works so well. And secondly, the way they sort of reset all your recommendations, right? Your recommendations and the sort of list of songs that are there, they don't accumulate. It always resets. And there's also an option for you to kind of clear your preferences. And that's something you will see in a lot of systems today, where you can go to YouTube and you can clear all your previously viewed videos. You can go to Google and clear all your previously viewed search terms. What that basically does is now it removes any pre-existing bias that was there in the recommendation system, and you can kind of start fresh. So keep these sort of things in mind so that users have this capability, and keep this sort of product scope, which is, frequency of use, frequency of update, how you're collecting feedback. These are key product decisions that need to be made as part of your AI product. And finally, you have to be very, very aware of all the data privacy laws that are coming into play. And that, again, also has to be baked into your product. You have GDPR laws in EU, and that's extending everywhere. You have your California Privacy Act that's come in for users, especially in California. And then you have the India specific personal data privacy laws as well. These are going to completely change the way you collect data, the way you interact with users. So definitely think about this and keep this in mind as you build your product. And a couple of quick points I want to talk about is we've actually the role of design is really changing for us as well, and we've coined sort of a whole new role of a new sort of job title we've had to come up with at Haptik, which is called Conversational Design. And it sits at the intersection of AI, user experience, and actually copywriting. And what conversational designers do at Haptik is actually they figure out what is the best way to write content such that you communicate the context of the bot. It communicates the capabilities of the bot, and it's able to fail gracefully and bring the user back on track. We've done a lot of research actually in just failures and how the bot would fail, and there's more AI in there actually than in a lot of other parts of the system. So we're seeing a lot of growth in terms of how design is even applied to these sort of systems, and with new roles and new titles and new experiences constantly developing, and new skill sets are being created. Great. And, coming to the next section, which is how do you set expectations now that you've built this product, with customers, internal stakeholders, and how do you manage what they can expect from your product? So, one thing people are still kind of getting a handle on is that AI is probabilistic, and you are not be able to sell anything with a guarantee. And this is a very different way of selling something, a different way of absorbing something. And we've had a lot of challenges when it comes to these sort of scenarios. And let me take a couple of examples here, which is when a lot of times we sell call center automation software, and we'll sell chatbots where customers will say, you have to guarantee that the bot will work for XYZ. And what happens there is that you can't make that guarantee, because you're selling something that's going to work 80% of the time. And then people look at that remaining 20% and say, but what about that? And they try and bake those into the contract and say that you have to guarantee an 80% accuracy, guarantee a 70% accuracy. We had a customer who actually did, ask for a guarantee in the contract, and it caused a lot of problems. So what happened actually was, they used to look at the system and say, you guaranteed us 80%. And they should look at the accuracy of the bot. Now, the challenge with this is when the bot replies to a particular statement, it's replying with the thought that it is correct. So you can kind of get, we don't really know the accuracy of a real-time system. We know the accuracy based on the training data, and calculating accuracy for a live deployment is always going to be a manual effort. Whatever anyone else tells you, you cannot get real-time accuracy from an AI system. It's going to be sort of it's going to be precision. You can't get sort of recall. Um, so be wary of those sort of contracts which kind of force that accuracy upon you. It will result in a lot of sort of manual effort. Keep an eye on the data ownership, the privacy policies in the B2B and B2C. Like I mentioned, data privacy laws are very, very stringent in terms of the data you collect and how you use it. That has to be factored into sort of taking consent from users, taking consent from a B2B environment as to how that data is used and shared. The fourth part is, very key in terms of how you market and position your product. You'll see a lot of AI washing happening these days, where people, talk about just they want to include the keyword we are using deep learning, we are using neural networks, without really sort of applying that in the correct context. And after a certain time, customers are able to see through that very easily. What you want to market and what you want to focus on is the value. So we try and say, hey, we will reduce your customer support cost by so much, rather than, hey, we use this deep learning technology. That really goes the distance, and that will take you further than just the hype that's there out there today. The key value prop that you're offering, the key thing that a customer can get out of it, rather than just they deployed AI. So while it's tempting to sort of say, you are an AI company and you are just sort of using the latest technology, focus on value. It's really important. And that's really tied to the last point here, which is who you sell to and who buys your product. If you're selling to sort of an innovation team or an offshoot of a marketing team, then they're buying that AI hype and they just want to sort of market themselves as an AI driven company. That will last, and you will make that sale, and it'll last you 1 quarter, it'll last you 2 quarters, but eventually they're not going to see value in your product outside of the hype that they just received. Always sell to an operational team. The operational team will always ask you, what is the value? How am I benefiting? How is it affecting my top line? How is it affecting my bottom line? How will my end users get benefit? Rather than I deploy AI and that sort of, you've gone beyond the hype and you've gotten the value again. Be very, very clear on what your system cannot do, what AI cannot do. And that is super, super important. Keep that upfront and, keep that sort of front and center. Do not missell, because it will come back to bite you again. An example that we have today is, with voice technology. ASR today really, really struggles to collect uh, pronouns and addresses, right? And a lot of time people want to be able to collect that over voice. And we try and make that as clear as possible that the technology is just not there today. If you want to collect people's name, let's say, for example, you want to be able to tell a bot that my name is Prateek. Now, that's something a person can't do today. How are you going to spell Prateek? Over the phone, a lot of people spell my name Pratik versus Prateek. How do you expect an AI system to figure out that difference when people can't do it, right? So these are the limitations of technology today, and it's very important to be clear about that rather than again try and sell something which you know is not going to work. The second aspect is really around services. So while you're really selling a product here, every AI business, due to the nature of it, is going to have some amount of services component. Um, Especially if you're selling something a little different to each customer, right? Uh, the data that I mentioned earlier on, that data needs to be collected, that data needs to be added, that data needs to be tagged, and that is always going to have be a manual process which either you need to bake into your product or bake into your business model somehow, and that's an ongoing effort. You're going to notice that we have to constantly keep maintaining our bots, because the model drifts. The intents that people are asking about now have changed with the intents that were there earlier. The data that was working 1 year back is no longer working now, so I have to keep adding new data. I have to keep maintaining the product, and I have to keep sort of updating the data set for which the model was built on earlier. So that analytics system and that management and is always a lot of overhead for any sort of AI system that you build, and that needs to be baked into your pricing or your product or your business model in a way that covers those costs over a longer period of time. Great. So, I think I've covered a lot of things from the beginning to the end over here in terms of finding the use case, uh, defining what the business outcome is going to be, building your product, making sure you have enough data, and building the correct design for your product. As you can see, AI is no longer, machine learning is no longer just a data scientist sort of discipline. There's a lot of different fields coming in to make a successful machine learning integrated or AI integrated product. You have design, you have operations, you have how you market and sell it, and how you have, and obviously, the product manager's job to bring all of this together. A lot of the core software design principles remain the same. Keep your cycles tight, keep your deployment cycles short, build something that's, build quickly, get a product out there. You'll realize that it helps you acquire more users, which helps you get more data, which in turn helps you get a bit sort of better product, right? So that's sort of the AI cycle loop of virtue. You want to focus very, very key on value generation. You want to make sure that you're really building something not just for the sake of AI, but it's actually adding some sort of key user value, business value to what you're building and deploying. Keep your iteration small and rapid, like I said, and build a long-term data strategy that will really, really help you go the distance in terms of not just the functionality you're building today, but also a year, 2 years, 3 years, 4 years, 5 years down the line, where you've realized that you've collected so much wealth from the data set that you've employed. You might not know what to do with it today, but 2 years, 3 years, 4 years down the line, you'll be really, really glad that you just collected and sort of had that data. And how to build a data strategy is obviously a conversation for another time, but I'm sure you can find a lot of content around there as well. So great, that's my talk for today, guys. I hope it was helpful and hope it was valuable to everyone here. I think we have maybe another 10-15 minutes for questions now.
Brilliant session, Prateek. Really great insights. And yes, we do have questions already lined up for you in the Q&A window. Just have a look at it and I will share my
Great. Bring up this section.
Okay, so audience, please ask your questions in the Zoom Q&A window or on the LinkedIn thread, and I will route it to Prateek. So let's take the first question here, Prateek, from the Zoom window. So this is from Asit, and he's actually very eager to have a discussion with you. I see so many questions from him already. So let's start with the first one. So he asks us how we can use UX and UI and design for artificial intelligence deep learning application, where most of the application have very limited interface to overcome limitations of technology.
No, great question, Asit. I hope I covered some of these points in the talk today, where we talk about, one is setting expectations with the user, clearly communicate the limits of the technology, send out the confidence, share the confidence values, share the probability values. Secondly, you want to always design for failure. What happens when you set a threshold and the result is below the threshold? What if there's not enough data? What if something else has gone wrong? So always design for failure, and always communicate to users in terms of uh, what sort of the GDPR and the legal rules are there, and always make sure you're collecting feedback and sort of labeling. It's essentially a way for customers and your users to label that data back for you, so that you can integrate it into the next iteration of your model. So there's these are 3 or 4 key points I would say where UI UX really comes into play when you're building ML applications.
I think that covers his next question as well, Prateek, which is how can we optimally use UX for AI to build products? Would you want to elaborate a little on that?
Yeah, I think there's a bit of the sort of the same sort of points over there. I
Right.
would say in terms of, specifically around user research and user experience. One thing I would also just like to add here is try and educate your designer, whoever is doing the design, as to how the technology works as well. It's very important for everyone in the team to have that background, not just sort of the data science team or not just even the product manager. Everyone from the marketing to the designer should get an understanding of what the technology really is. I mean, without getting into the technical math details or but what it's really doing, so that they can apply that in their design.
All right. So I hope that answers your question, Asit. Coming to the next question from Shivaji. I see IoTs with AI are coming up rapidly, and what could be the major revolutions in that area? What are the chances of blockchain based decentralized applications using AI?
No, good question. I think, especially around the IoT section. What's really happening with IoT is that it's exponentially increasing the amount of data that's available. So let's say you now have sensors, you have the ability to take action, and say in an industrial setting or what have you, where you're getting so much data in right now, which was earlier just not there or just not possible. Um, I think that's primarily the systemic change I see in terms of how IoT can be coupled with AI. With these new data points, let's say you're now tracking, uh, let's say, for example, weather data or pollution data or wherever else you've deployed these items, you can now use that additional data points to then do some of the same similar things that we spoke about. Apply those same 6 or 8 models to come up with those same problem statements across a much, much broader data set that you've collected now. And then using those devices, you can quickly take action as well. Regarding, regarding blockchain, I think that's a technology I would say is has a very interesting application specifically around data privacy. Today, I think that's been one major struggle in terms of we're going to see a lot of different policy changes and new regulations and laws come in to manage data ownership and data privacy. You have PDP laws, and then you have the NPD law as well. That's being tabled for discussion in India. I think a blockchain system deployed over there has some very, very interesting possibilities as to how we can manage ownership of data, and that could potentially open up a whole new slew of possibilities again.
Great. So Shivaji, I hope you answered, Pratik answered your question. So coming to the next question, this is from Sanjeev. How to make data marketable if it is not getting any profit?
Not sure I quite understood your question, Sanjeev. How to make data marketable? Um, I think in the end, you're not really. We have. Let me know if I've understood your question correctly. But you're not trying to like really market the data or sort of the collection of the data. Always keep your narrative both internally and externally focused around the business value. So, whether it's not about the data you're collecting, that is sort of it's a strategy. Yes, it's not even about the type of ML model that you're deploying. It's always about what are you trying to achieve from that data. What are you trying to achieve from sort of collecting that data and deploying that machine learning model, right? So is it more stickiness for users, more engagement with a lot of NLP technology? We're seeing it's all about reducing cost, reducing manual effort, and hence reducing costs. It could be about increasing and selling better and increasing conversion rates. So focus on the business value and market that rather than marketing any technology or the data, and that's it.
So we're taking this next question from Sri Ram Kishore Kumar, who is on LinkedIn. And this is a rather interesting question, Prateek. Do you have any plans to update the human in the loop mechanism? Any possibility of removing the human from the equation, say based on the feedback at the end of the chat? Example, if the user says they are satisfied with the conversation and got to the required information, then you use the data to train the model, else not use it.
That's actually, it's a great question over there. Um, and it's actually something that we consider a lot, and so which is using the user's feedback as directly as a way of saying that this training data is correct and this training data is accurate. And there's a reason we didn't decide to go ahead with that, because I can take an example of someone else who had tried that earlier. I'm not sure you've heard of the Microsoft bot that went out. It's called the Tay bot. And what that actually did is it was deployed on Twitter, and it was a completely generative machine learning system, which is it had no sort of responses defined, but by actually conversing with users on Twitter, it actually learned what to reply back. And what happened over time is that bot ended up using racial slurs. It sort of started becoming and started learning abuses from users, and kind of started learning the wrong things. And then they had to pull. It was a big sort of PR nightmare for Microsoft, and they had to pull that down. So essentially, it's very, very risky when you rely on, you wouldn't let someone else inject code into your system, and you shouldn't let someone else inject data into your system. You're giving control out from what you are, you're giving control of the system to someone else.
Thank you for that question, Sriram. And so we'll take this question from Amit next. How can we integrate AI and ML within the context of manufacturing industry operations, as it is crude in terms of technological initiatives, as it is mostly human dependent? Was I clear enough, or you could read the question, the Q&A, Prateek?
Yeah, yeah, it's very clear. Thank you.
Okay,
As
right.
well. Yeah, Amit, and here I think I would say, not sure if I would agree here. I think maybe Indian manufacturing might be a little sort of behind as compared to other countries, but I know that, and I'll take a couple of examples that I know AI and machine learning has been deployed to great effect in the manufacturing industry. Uh, Tesla, for example, has a nearly completely automated assembly chain where they use robotics to kind of assemble the cars. They use image recognition and image processing technology to kind of on the cameras, on the robotic arms to see where different parts should go as well. We've deployed a lot of AI and machine learning in the agri-tech industry um, in Amsterdam and the Netherlands, where almost the entire farm has no manual intervention whatsoever. The AI system detects when the plant needs to be watered, when the through the camera you can see sort of if there's any fungus growing on the plant and what sort of herbicide needs to be added. It knows when the fruits are ripe again through a different sort of image processing capability. It automatically moves and harvests the plants as well. So we're seeing a lot of huge applications in the manufacturing industry. um, I'm not a part of, maybe we haven't seen so much of it in India because perhaps labor is still a lot cheaper. But I mean, I'm not a part of the manufacturing industry, so I can't say as well as much about that. But we've seen a lot of it definitely in very specific industries abroad.
Great. So, Prateek, given the limited time, I know it's already past 9, but we'll take this one last question and then we'll conclude the session. So, this everybody would like to know actually. As a product manager for AI product, what are the challenges you found while collaborating with design, data science, engineering, marketing team, including customer and other stakeholders?
Um, no, great question, Aseed, and I hope I covered some of those in the talk today, but I'll kind of reiterate on them as well. Um, the main thing I would say is a lot of the other teams sometimes don't know how AI really works and how much sort of machine learning works. That's specifically a problem I would usually see with the marketing team or the customer success team, sales team. So focus on a lot of education over there, a lot of kind of explaining as to what the technology is, how to deploy it, and again, what are the core value and that you're trying to get out of it. Um, with, with regards to sort of the data science and engineering team, I would say is a slightly different problem. They're obviously well aware of what they're trying to do and what the technology is, but sometimes they're unaware of the other side of the problem, the other side of the fact, which is they don't know why they're doing it. They try and get carried away with get carried away with over engineering solutions, spending maybe too much time making sure building a very complicated model or building something that is not focused on outcomes. I'd say that's one problem with the engineering and data science team. How do you keep iterations very rapid and quick? Um, that's the second problem. The third problem I would say is in estimations. Uh, One way where machine learning problems are different from traditional software development is it's very hard to get estimates, and that's an understandable problem because what happens is you're trying out a lot of different techniques and a lot of different models, and sometimes you just hit a dead end and you have to kind of throw away what you have and start again. So it's a lot of experiments. So a lot of times, the same team will try and come to me and say, "How long is this going to take?" And that can be a really hard number to arrive at, and I kind of know why it's a hard number to arrive at. But that's something that is a struggle, and that's also a part of the nature of the work as to how do you make things a little more predictable, how do you give estimates, and how do you kind of manage those expectations over there. And yeah, and another sort of quick one I would say was with the sales and marketing team, which is the customers themselves are a lot of times, uh, very focused with, I want a deep learning solution, or do you have the best AIs? And a lot of times applying AI when it's not even required. So I think that problem statement kind of bleeds into problem with obviously sales and marketing trying to give customers what they want. So managing that expectation directly with the customers, where again educating customers in terms of what the technology is, why it is this way, how it works, how they should also focus on their business value, and then following through with that on the marketing and sales side.
Awesome, Prateek. And audience, in view of the time constraints, we will have to end the Q&A here. Thanks for the participation. And for any further questions and the questions that we weren't able to answer, please connect with Prateek over LinkedIn or other mediums. I hope that's okay.
Absolutely. Do reach out to me on LinkedIn, on Twitter, or you can email me. My email address is Prateek, Prateek, Gupte, Gupte @gmail.com.
Right, moving on to the final part of the session, Prateek, we'll need your help declaring the champion of curiosity today. So among the audience, whoever asked us questions, we will be picking a winner and he will be rewarded with a free digital course. So please help us choose a winner.
Ooh, that's a tough one. I think a lot of great.
Right, so you can see the questions actually in the answer tab in the Q&A window itself, the ones that we took. And also we did take one question from LinkedIn as well. So that is there.
Yeah, I think the LinkedIn question definitely stood out for me. I would say that is the winner of a great question, which is so I don't remember who asked it, but they were asking about why don't we ask users to label the data and have the feedback kind of train the bot again. So I think that was a great question. I think I picked that one as the winner.
All right, so the winner is Sriram Kishore Kumar. And congratulations, Sriram. We'll get in touch with you shortly with the reward.
Awesome. Congrats, Sriram.
We have enjoyed having you with us, Prateek. It has been a complete pleasure. Please accept the certificate of appreciation from the Institute. So if you scan the QR code on the certificate, it will take you to a dedicated Hall of Fame page that we have created for you with the recording of this session. Please share it within your network and we'll share the webinar recording on the YouTube channel as well.
Awesome. Thank you so much for having me.
We are grateful for the time and effort you took to share your thoughts and amazing insights, Prateek. And I'm sure the audience can definitely benefit from the methods you suggested. Thank you once again for joining us. It was a great session.
Thank you. Cheers. Have a good day.
And audience, thank you for joining in. It was great interacting with you all. Do not forget to register for the upcoming webinar tomorrow. With that note, I end tonight's session. Happy learning and stay skilled. Have a great night. Bye, Prateek.